everybody. MS-DOS, welcome. Today's lecture is, and this time we promise, is actually really short. 10 slides short, to be exact. So I'm going to be talking a little bit about something that is a bit more oriented towards OS 10 Mac app development. I know it says view and window controllers, but what I'm going to be talking about specifically are window controllers themselves. Kevin has been talking about view controllers. They work the exact same way on OS 10, but you've got another layer on top of that that you can use that are subclasses of NS window controllers. So technically, NS window controllers are view controllers. They're not subclass from them, but under the hood, OS 10 treats window controllers as view controllers. They're typically used for document-oriented applications such as word processing or numbers like Excel. They're typically used for when you've got a window that has specific functionality that may have multiple copies of data that are within them, or they contain their own separate data in different windows, but you want the same core functionality across all of the windows. A lot of people try not to use NS window controllers, try not to necessarily use NS window controllers, mostly because as you'll see, or as you've seen with the Bouncy and Bouncy iOS, if you just stick to view controllers and just use the default window controller, it makes porting over to iOS devices much faster, much simpler. Typically, iOS devices don't have multiple windows. Typically, it's just one window with many views. So a lot of people will just try and stick with the standard Mac window controller, use view controllers instead, and it makes porting that much simpler. However, if you are doing a document-centric application, it makes a lot more sense to use a window controller, and I'll give you some examples of that. So typically, window controllers are used for these five specific things. Loading and displaying a window. If you've got a nib that has a window and a window controller in it, and you want to handle when events occur before and after the window is loaded and displayed, that's why you would want a subclass, an NS window controller. Create your own NS window controller. Closing the window when appropriate, like the OS 10 underneath, when you quit and it asks you if you want to save documents, well, used to ask you if you want to save documents, auto saves them now. It would send a close message to your window, and your window would automatically close. There may be other times where you want to close windows that isn't necessarily tied to quitting the application. If you have a button that says, show me these palettes, and another button that says hide these palette windows, then you may want to be able to close the window programmatically instead. Customizing the Windows title, of course, you can do that in Interface Builder, but if you've got multiple windows and you need multiple titles, using a window controller is the easiest way to do that. Storing and keeping the Windows frame and the size and the location of it is done automatically in Lion. If you want to store it as a default, you can do that in Interface Builder for one of your windows. If you want to do it for multiple windows, you want to use an NS window controller, and you can store any of your windows as frames and sizes, bounds, and where they are on the screen. You can store them as default so that any new windows that open up will, of certain types, will open up in specific locations and specific sizes that you have specified as defaults. And then also being able to cascade windows in relation to other windows, whether you're tiling them, resizing and tiling them, or you're stacking them up into neat rows just for the user. You'll want to use a window controller to handle that functionality. So Apple's kind of bottom line is if your document requires or allows multiple windows for one single document, and I'll show you an example of that, it's a good reason to subclass the NS window controller. So obvious cases, the CAD programs are usually the standard example for this. Typically you've got multiple windows open that are showing you the same data in different formats. The windows themselves have different functionality, but the data within it is the same. Here's another example where you've got a floor plan, and then you can see the overhead floor plan, and then you can see, say, areas where you're calculating dimensions. If you've got data that you want to view in different formats, and you want to have different windows that you can control and resize and tile like this, that's when you use an NS window controller. So typically, when you subclass NS window, the three most common methods to overload are window will load, which means that as the window is being loaded from the nib file, right before it loads, you may have some setup that you want to do first. This is where you would do that. If, say, you had some crazy defaults, or you had a new font that you knew the specific width and height of, and you wanted to make sure that the window was sized that way before the nib came in, and that you could apply to it. That's where you would do it. Window did load is what you want to is called as soon as the window is loaded from the nib and it's loaded and created in memory. You may want to do some, say, positioning or tiling as soon as the window is loaded. In the nib, you can specify location, but say you want it to be in the lower right-hand corner, upper right-hand corner of the window, of the screen. So you want your window in the upper right-hand corner of your screen. Since screen sizes are different, you may have to do that algorithmically. This is a good place to do that. As soon as the window is loaded, you can figure out where to place it on the screen and place it there. And then the other obvious one is window title for document display name, to be able to set the Windows title to anything you want. Typically, it's the name of the file that's associated with a window. So one of the gotchas is the NS window controller, as it starts up, it expects that init with a window nib is a method that is within your subclass. If you subclass the window controller, that's generic NS window controller behavior, is to just load up the window controller, call init with window nib, and it's the same nib that holds your controller, so everything's groovy. So it knows how to load your window and associate it with the window controller. Unfortunately, when you subclass NS window controller, typically you're doing that for user interface items that aren't necessarily associated with that window controller. So it turns out to be pretty hacky to try and call this init with window nib, or load your own nib yourself and then go through and set up your user interface elements. So this all refers to the disconnect between your window controller nib and, say, another nib that has your window and view and controls within those views. So typically the way to handle that is to override the init method inside of your NS window controller, and then have your init method of your subclass window controller call super init with window nib name, and give it the correct name, that the correctly associated nib name for that window. Unless you use this quite a bit, this probably doesn't make a whole lot of sense. It's not super clear. The bottom line is that on OS X, if you're using window controllers to view data in different ways, view the same data in different ways in different windows, or you have windows that are associated with different documents, so you need different formats for your interface controls. Having a way to subclass NS window controller is the natural way to do that. Unfortunately, the association between the Windows nib controller and the window controller's nib aren't necessarily one-to-one, and usually aren't one-to-one because you want to keep that separate. So the way to handle that is override in your subclass, override a init, and call the super window controller's init with window nib name and give it the name that is associated with your user control. That probably didn't help very much either. So using this is the easiest way to understand it. Like practicing with this is the easiest way to understand it. If you're doing mostly iOS development, however, you probably won't be using this very often. So,
in fact, you won't ever be using it because you don't have window controllers on iOS.
so there you go. So if you're strictly iOS development and you're not trying to do any kind of cross-porting, then you're not going to get any practice with this. But just like all of the other Apple developer documentation, there's a ton of documentation on NS window controllers and when to use them and how they're used and how to handle this special subclassing. And so if you've got a nib file that you've got an NS window controller in, you need to set. Typically, when it loads, when your nib file is loaded, it sets itself as the owner of that nib file. To have connections to the window controller to other objects that are in the nib file, you have to set the file's owner to the nib file that will be managed by the custom window controller. Blah blah blah. Here's what it looks like. So, if we have our NS window controller here. Not a ton of real estate. We want to make sure that our file's owner for our NS window controller is the name of your subclassed NS window controller. You have to do that. Otherwise, you're not going to be able to connect to objects in your window or connect your window to your window controller. The window outlet in your NS window controller. There's a window outlet that is specifically associated, your NS window controller that's specifically associated with a window, much like an NS view controller is associated with a view. To be able to have your window controller automatically associated with a specific window, you have to actually make this connection yourself. So once you've set up the class, your file's owner class, you'll see this is my window controller zip file. We've set the file's owner to my window controller. Then you have to actually go and explicitly connect the window to the actual window itself. When you make that connection, your window controller and your window are bound together, just like a view controller and a view.
If you fail to do that, you'll get some really weird exit errors. And the same thing will happen with view controllers and views, actually. If you don't hook up the view outlet of the view controller, it will just crash immediately when it tries to load the view.
That's a good point. So controllers they expect to be controlling something. And if you're not programmatically setting that up, and you're expecting this to work from zib or nib files, you need to make sure that the objects that they control are actually connected to the controller class. And if you've got a separate controller class, a separate controller zib, remember that's the file's owner. The file's owner type is going to be your controller type, which is right here. Another optional thing that you may want to do is have your window controller also be a delegate for your window controller. You don't necessarily have to have that, but if you do want to do that, you need to make sure that your delegate first you need to make sure that your NS window controller here implements the NS window delegate. Once you do that, you can switch to your zip file and make sure that you'll see under.
You have to go from the window to the file zone.
There we go. Yeah. So we want this window associated with our window controller as a delegate. And you guys are going to get some more practice with delegates if you're
in today's lab.
If you're kind of hazy or rusty on it from last lecture and the lecture prior. So if we don't want to specifically subclass a window, we just want to make sure that our controller is responsible for handling events that are coming in from our window. We need to make sure that the Windows delegate is associated with our window controller. Remember, our window controller is our file's owner. So events that happen in the window will be handled now inside of our window controller. Pretty sure that's it. Yes. Okay. So, lab today, you'll be practicing with delegates. You'll be doing some of this, and Kevin has got some more.
Yeah, just sort of quickly, I wanted to talk about doing on-device testing, because it's a little bit complicated to get working. So the free Apple Developer Program sign-up that you can do allows you to do testing in the simulator, but it doesn't allow testing on device. Berkeley has a university developer program with Apple, so that it allows on-device testing, but no distribution whatsoever, so no ad hoc distribution, no App Store distribution, but it has on-device testing. So today I'm going to send out invitations to everybody in the class to join this developer program. If you haven't done so already, you should create an account with Apple on developer.apple.com, so that way you can log in with that account and just be added as a member of our team. And then I will put some instructions on the homepage of the hoops you have to jump through to get to test on your device, because there's quite a few hoops. But just look for that email. It's going to be whatever email is associated with DSpace. So I think which I think for everybody is their Berkeley email. But so look for that and make sure that you signed up with developer.apple.com and just kind of go through those steps. One thing that people always wonder about is they ask for your company. You can either put your own name or put like UC Berkeley or something. That's what I usually do. So they won't let you have it. They won't let you sign up without a company, which is kind of weird. But that's it. And the lab will be up in just a minute.
While he's doing that, does anybody have any questions about window controllers or view controllers, or what their role is in the MVC pattern, why they're useful?
Yeah, I know we didn't talk about them a lot, but they're actually pretty important.
They're really key in managing and being kind of a manager between your view and your model, your data and your calculations and your display. They're the ones that are kind of the traffic cops that are shuttling messages back and forth between the two, so that your view can change and your model doesn't have to change very much, or your model can change and your view doesn't have to change very much. If you saw in the bouncy to bouncy iOS transition, the view controller, the view didn't have to, or the view changed a little bit. The model didn't have to change at all, and the controller had to change very little as well.
Okay, the lab should be live now, so have fun.